The inner working of the machine implementation was a polyalphabetic substitution. Hello, today we are going to know what cryptography is and the importance of cryptography. So cryptography, it is the process of encoding plain text into an encrypted message which can be decoded only if you have the encryption key. So basically cryptography has two steps. The first one is encryption, in which we take the plain text using a encryption key, we transfer it into a cipher text. The second part is decryption. In this process, we take the cipher text and using the decryption key, we convert or basically we decode or decrypt the cipher text into the plain text. In cryptography, the important term is cipher. Cipher is the method of scrambling your text so that you are able to hide it. So there are two main types of ciphers. One is substitution cipher and the second is transposition cipher. Let us first check what a substitution cipher is. As the name suggests, in a substitution cipher, we substitute each character of the information or data. So one of the most famous was Julius Caesar cipher. So basically in this method they used to substitute each letter by +3 or by +x. So Julius cipher, it is a type of substitution cipher. Suppose if we say that the encryption key is +3 to the right. Okay. So in this way, we would be shifting each character by 3 to the right hand side. So basically H, it would become K, E would become H, L would become O, and O would become R, and D would be G. Okay. So this is the cipher text using the key of 3 to the right. If we want to decrypt it, it would be 3 to the left. So this is the decryption key. We would be shifting K 3 to the left. So K would become H, H would become E, and we would get our plain text. So Julius cipher was substituting only one character. So it was easy to decrypt it. There is another method which is called polyalphabet substitution. So basically in this process we substitute each character by multiple ways. So basically the first character you substitute by +3, the second character you substitute by +4. One of the most famous polyalphabetic substitution cipher is Vigenère Cipher. Vigenère Cipher is a polyalphabetic substitution cipher in which each character is basically substituted by a different character. The row is a combination of A to Z, and then we have first row starting with A, and the second one it is starting with B, okay, and then it is Z and then repeated by A. In the same way we have the third one starting with C. In the same way the column also, the first column is starting with A, the second column is starting with B, third is C, and the last one is starting with Z. First define a key, then using that key we would be encrypting our message. Suppose we have a text of secret message and we say that our key is apple. Okay. So in this case, for each character, we would write down like whatever is there, apple, and then again apple, okay, and then again app. So basically for each character of our string or the plain text, we have one encryption key. So this encryption key, we would be referring the row in the matrix, okay, and our plain text would be column. So basically S has A. So for the S column, this is S, right? And we would consider column A. So we have first letter S. So we would write down here S. E has the encryption key of P. This is E and then the encryption of P. So it is coming T. Okay. E and P, the letter is T. So we would write down here T. So in the same way, we would be encrypting each and every message. So it would be like BTDWAVT. So this is our cipher. Now to decrypt it, we would again use the same key. So it would be like APPLEAPPLEAPP. Okay. However, now when we want to search, we would first search by in this row, and then we will try to find out the character in that row, and then the column name would be our plain text. For A and S, we would first look at the row A and then try to find out S, and then the column, it would be our character. So in the same way, we would be able to decrypt the message. So this is the advantage of using a polyalphabetic substitution using a matrix. Even the same characters are encrypted with different values. One of the most important crypto systems was the Enigma machine. It was basically created by the Germany to provide secure communication between military and the political units. So as you are able to see the machine, it looks just like a typewriter. So there are major four parts. This is your keyboard, basically something where we would be entering our input. So this is like a output. Okay, so when you click N, then based on the substitution algorithm, a light would blink indicating the output. These are the routers. So basically this is like one of the combinations. So they would set these routers, and then also if you are able to see, here are also there are certain wires. Okay. So basically we would be again creating a combination. So the Enigma machine, it was using a polyalphabetic substitution. So let me explain with a different image. So as you are able to see, this is a router. So the router, it was used for a combination, basically the substitution algorithm, and also the plug board, where the operator would, put in the wires and again create a combination, and this was the input. So basically, as we have learned in the polyalphabet substitution, whenever maybe if they press A, and based on the encryption, which is the router and the plug board, a light would blink indicating its cipher value, maybe P. Okay. So in this way, the plain text, it would be converted into a cipher text based on the combination of the routers and the plug board. And then to decrypt the message, they would do the exact opposite. They would enter the value of the cipher using in the keyboard, and then they would get the value from the output. This is how the Enigma machine actually worked. The inner working of the machine implementation was a polyalphabetic substitution. To break this cryptographic system, the Allied forces, which was headed by Aaron, they created a decryption machine. The decryption machine, which Aaron and his team created, it is basically the pioneer of the today's computer. So it is said that today's computer evolved from the machine which was created for the decryption of Enigma. So friends, if you like this video, please do subscribe.